So here's the architecture that we've come up with. And again, it's a functional architecture. It shows functional blocks. This doesn't necessarily translate into a software implementation, but conceptually, what we're proposing is that as part of your SDN infrastructure, either running in the controller or somewhere with the controller, you have a new module that we call the Automated Quality of Experience module. And that module has at least 4 submodules. One would be the Dynamic QoS Marking module. That's the infrastructure that lets applications identify traffic to the network and request QoS treatment for that network. You might have an admission control module that lets you request bandwidth associated with those sessions, and that admission control module would then also regulate access to the bandwidth resources. You might have traffic engineering done dynamically, so you can optimize the available bandwidth in a more dynamic fashion. And then all of this would be governed and regulated by a policy module, because anytime you have resource allocation algorithms or what have you, there's different policies you can apply to decide who gets access to what. So by definition, I think there's a policy capability or component that needs to be part of this. And then we'll have automated QoE APIs that UC system can use. There's an administrator interface that we envision defining at some point, but that hasn't been done in the context of the current activities. Now, as it relates to the interfaces and the use cases, I said there's 4 modules. We don't envision that one would have to deploy all 4 of them to get started with dynamic QoS. In fact, if all you want to do is mark your traffic and identify traffic on the network, you can start with a QoS marking module. So that's sort of the minimum required if you want to get value out of the UCSDN infrastructure. Now, optionally, you could add admission control to that if you want to make decisions about bandwidth. And then a further option would be to add dynamic traffic engineering to that if you want to do dynamic reallocation of bandwidth and rerouting and those kinds of things. So this is how we see a deployment evolution of these types of capabilities. Now, as it relates to QoS marking, let me just walk you through a scenario of how we think this would work. So I'm showing here a fairly trivial network infrastructure where you have a network backbone connected to some branches in a data center. You have UC infrastructure deployed in your data center. You have voice over IP phones or UC systems deployed in some of these branches. And I'll walk you through a scenario of how the various components interact to set up the QoS infrastructure dynamically. Now, the first thing we envision happening is when the UC&C infrastructure first starts up, when it comes up on the network, it will tell the automated QoE service that it wants QoS treatment for all signaling traffic. Right? There may be reasons that you want to protect your signaling traffic or give you signaling traffic priority on the network. So the UC&C infrastructure would do that when it first starts up. It sends a message to the QoE service saying, apply QoS policy to my signaling traffic, and the signaling traffic would be identified based on the protocol that's being used. For example, mark all traffic at port 5060 to the IP address of my proxy server, for example. In return, the QoE server would then communicate based on its inventory of network elements. It would communicate with all the network elements to install the appropriate QoS policies on those network devices. This is sort of a brute force approach. You would proactively install these policies. If you use OpenFlow, you could also use what's called a reactive policy instead, which is the first time a network element sees a packet with the specific traffic patterns or the protocol patterns that you're specifying, you could ask the service what to do with that, and the service could, in a reactive fashion, install those policies. So different ways you can do this based on the OpenFlow or based on the SDN protocols that are being deployed. Now, once those QoS policies for signaling are installed, then your signaling traffic would get the proper QoS treatment. And I'm showing this here in green. So green means that proper QoS is applied. In this case, we're applying class selector 3, just as an example. Now that signaling traffic on the network with its QoS treatment would get routed typically through your infrastructure, whether it's your SBCs or your proxy servers or your 323 gatekeepers or whatever it is. So the infrastructure has visibility into the payload of the signaling traffic. Based on that signaling traffic, it could figure out where the two endpoints are or where the various endpoints are that will be involved in a call. It could extract that information and inform the QoE manager that we are expecting new traffic on the network between the addresses specified. Please give QoS treatment to that traffic. Now, in the meantime, this is all running in parallel with the call setup. So we're not blocking call setup to get to take care of all this behind-the-scenes QoS management. So media traffic will start flowing, but it won't initially receive the proper QoS treatment. So that's why this is shown in red, suggesting that all it gets is best efforts treatment. Now the QoE service would from there then install, based on its topology, it would install QoS policies on the ingress network elements in the network. So the network elements where the traffic from the endpoints enters the network. And once that happens, the traffic would get automatically upgraded to the proper class of service. In this case, if it's voice traffic, you might want expedited forwarding. And the result of that is that you now have dynamically ensured QoS, all driven by your UC infrastructure communicating with the QoE service. So that's a very high-level, quick introduction of how the flow works. From an interface point of view, we proposed in the activity group, we proposed two different interfaces. One we call the session-based model, which installs dynamic policies that are to be applied to voice and video sessions. It's very REST-centric, so you have a create, read, update, delete. For signaling traffic, we have something we call a policy model, which is much more static, and it uses the same REST approach. There's a data model associated with those interfaces. There was a question yesterday about whether that data model is SIP-specific. It isn't. It has a notion of a session as a whole, which may have a user associated with them, but the important elements in the session element are the various media elements, because any session you typically have at least two media streams. You have bidirectional voice, so you have one media stream for each direction. If it's video, you may add one or more video streams, what have you. So you have multiple media elements associated with a session. Each media element uniquely represents a flow that's identified by a 5-tuple on the network, and also we want to make sure we support IPv6, so there's an IP address type field in there. And then very importantly, what we imagine is that the flow would have a requested QoS element that says to the network, here's the QoS treatment that I'd like to receive, and then in return, the network would send back to the UC infrastructure, here's the QoS treatment I'm actually granting you based on either policy or based on available capacity of the network. And it's that interaction between the network, the sort of request response, that lets you optimize within the constraint of what's actually available and within the constraints of what the policy dictates. And in the interest of time, I won't go into detail about the control flow, but the idea is that the QoE service would process these elements. Clearly there's a number of policy items that need to be addressed. We express, or we envision, that QoS treatment is expressed not in terms of low-level QoS markings, but instead in terms of higher-level class of service concepts. So you may have a class of service for real-time voice, for real-time video, for streaming video, what have you. Those classes of services will need to get mapped onto low-level QoS markings like diff-serve code points or WM markings or whatever else, 801.1p markings. But that's up to the implementation and could get done by a QoS mapping. And the specifics of the policy will be part of further work that we'll be doing over the next couple of months. So in the interest of time, I'll just stop here and open it up for a couple of questions.